Today I'll talk about PdV work in various quasi-static process. Now PdV work. So quasi-static process. Now consider a piston moving from thermodynamic equilibrium state. So this is thermodynamic equilibrium state 1 to 2. In state 1 it is that pressure is P1 and volume is V1, to state 2 P2 and V2. So let the values at any intermediate equilibrium state be denoted by P and V. Now if I plot, so we'll get this type of curve. Now if we want to find out the area under the curve PV between state 1 and state 2, that represent actually work done, so that is nothing but PdV, and here A represent this area. So now as it is a quasi-static process, so it will give that infinitesimal work. For an infinitesimal displacement, that is dl, the infinitesimal work done is given by dw f into dl, that is p into a into dl, that is nothing but PdV. Now so work for process 1 2, so the total work done for the process from state 1 to state 2, w1 to 2, is given by integral of PdV form. So that is w1 2 is nothing but integration of v1 to v2 PdV. Now that quasi-static process path, the path followed during the process from 1 to state 2 is represented by P and V. This process is quasi-static, mean it occurs slowly enough to maintain equilibrium at the each step. Now that PdV work, so that is w1 2 is nothing but v1 to v2 PdV. So now we can classify or categorize a different type of work or different type of process of the work. So one is isobaric process, mean pressure remain constant. So work done is given by W is integration of v1 v2 PdV, as P is constant, then if we integrate, so we will get P v2 minus v1. So if we plot, it will nothing but a straight line. So volume will change but pressure is constant, so it will go state 1 to state 2. So it is called isobaric process. Now here is one example: heating 2 moles of gas at constant pressure P atm, where V1 is 5 liter and V2 is 10 liter. Okay, so now we can calculate W, so that is nothing but 5 into 10 to the power 5 joules. So we have to convert atm to Pascal, and then we can calculate that will give 5 into 10 to the power 5 joules. Now next is isothermal process. So here temperature T remain constant, so pressure P and volume V are inversely proportional according to the ideal gas law. So PV is equal to P1 V1 is equal to P2 V2 is equal to C is equal to nothing but nRT. So now that W will be V1 to V2 PdV. Now we know that we can change that P, so that is P1 V1 by V dV. Now P1 V1 will be out of the integral, and then if I do the integration, so it will be ln V2 by V1, and then if I change V2 by V1, so it will be P1 V1 ln P1 by P2. We can also write nRT ln V2 by V1. Now expansion of 1 mole of an ideal gas N is equal to 1 at 300 Kelvin in a piston cylinder arrangement where V1 is 1 liter and V2 is 2 liter. So we can calculate W is nothing but nRT into V2 by V1, so that is 2494 joule. Now next is isochoric process. What is isochoric process? So volume remain constant, V is constant, so no work is actually done. dW is nothing but V1 to V2 PdV, as volume doesn't change, so dV is actually 0, so work done is 0. So no work is done when heating 3 moles of gas in a rigid cylinder, means volume will not change. So that is, so here you can see that plot, volume will not change, so that is isochoric process. Now if that P and V, if it is a polytropic process, means P into V to the power n is equal to C. Now here the equation is nothing but P into Vn is nothing but V1 to the power n is equal to P2 v2 to the power n is equal to 0. So that is called polytropic process. So equation become P is nothing but P1 V1 n by Vn, P is nothing but P2 V2 n by Vn. Now we already know this equation, so that work done from state 1 to state 2, V1 to V2 PdV. Okay, so that we know. Now if n is equal to infinity, okay, so for that V is raised to the power of infinity, it implies that volume is held constant. So if volume constant means that work done is 0. If n is equal to 1, so that is PV is equal to nRT. So we'll get that P1 into V2 minus V1. Next, in the general case, when n not is equal to 1, we have a more complex equation for the work. So now here P1 V1 n by Vn by dV. So we can change that P. We can change that P here. We can change that P dot Vn. Here P we can change. So that will be P1 V1 n by Vn. So now P1 V1 n will be come out. Now it will be like integration of dV by Vn. So if we integrate, we will get V2 1 by n minus V1 1 minus n by 1 minus n. Now if I multiply and if we do simplification, so P1 Vy to the power n into V2 1 minus n and minus P1 V1 n plus V1 1 minus n. Now this will give P1 V1. Okay, now if I plug that P1 is nothing but P2 V2 n by V1 n. Okay, so here P1 V1 n is already there, so that will be P2 V2 n. So I plug that, and then V2 1 minus n. Okay, so already we have all P1 V1. So finally we'll get that work done from state 1 to 2. So that will be P2 V2 minus P1 V1 by 1 minus n. So for polytropic process, okay, so for n not is equal to 1, so that will be P2 V2 minus P1 V1 by 1 minus n. That's it for the PV work.